set up the link side scrolling objects create event so that we can get started working with him in game. So this time we are going to get started with the step event and setting up our first states. So let's get cracking. Come back to our link object. As you remember, we set up everything inside of his state event, his create event. So he's pretty much good to go in this instance. So our next step here will be the step event, which controls and directs everything else that's going to happen inside of this object. So we have a bunch of different things that we're going to be setting up in here, such as pausing. So we'll create regions for these things. Let's use a code snippet to create a region. 2, 3, 4, 5, 6, 7, 8, 9 of them, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go. A little space in between each one for my preferences. This just makes it easier to manage our code as usual. And we're going to need a pausing section here. We're going to need a ground check here. We're going to need a wall check here. So technically, you could probably combine these all into like one collision check section, but you know, it doesn't really matter. Just do whatever works for you. Direction update, or just direction update, or whatever. Talk box interaction. Transition check. It's where we prevent the player from executing states if you're in a transition. Damage check. Then state execution. Experience handling. Positional clamping. And lastly, timers. We'll go through the easiest ones to set up first, and we'll probably skip some of these things until later on, such as experience handling, damage, etc. So let's come back to our, well, let's see. We start from the top here. I'll just explain a little bit as we go with each one of these things. So with pausing, there's going to be a couple ways that we can pause our character. The first one being if we're in a transition. So if the trans mode does not equal off, or in this case, since I remembered that I had a function for this that I set up, if not transition underscore finished, and it just basically this. It's the exact same code. So transitional checking. Another one that you'll want to be careful about would be for a pause object. So remember back over in our game objects, I don't believe that we set up a pause object. Yeah, so come over here, create a new object. Pause. Give you persistent. You don't need to be, well, you probably want to be visible, because you might want to have the pause object create menus and draw menus and stuff. We had palettes. Where was it? Game object icons. There it is. Pause icon. All right. So we can just ignore that for now and come in with our pause object and pause the game. So we want to pause our game whenever we have a pause object. It's the same code there. And then last but not least, we want to be able to create a pause object. So if input pressed, input action.start. So if the players press start, then instance create layer, -32, -32, instance object pause. input clear, this is very important here. Your input action.start, and then image speed 0 and exit. The main reason why this is very important here is because if you don't clear your start input and you say you have you're telling your pause object, so you create your pause object by pressing start, but you also unpause by pressing start, right? So if you don't clear your pause action, you'll create the pause object and then immediately delete it again because you're telling the game to also unpause at the same time, because pause and unpause are on the same button. So you got to clear your button input so that you don't end up double inputting your pause creation or delete input. So you could probably avoid that with some clever programming, like basically putting checks for the pause into the begin step or something so that it skips it and doesn't get checked in here. But that's just me coming up with random stuff, so it always just varies according to your needs. So let's go over here to our 8 direction update. And we're going to want to put in a little bit of input check here. So start off X input and Y input. Input held right, input held left, input held up, input held down, subtracted from each other. This will give you a 1 if you're pressing right, a -1 if you're pressing left, a 1 if you're pressing up, a -1 if you're pressing down. So that's a very standard, easy hack that everybody uses. So make sure you do use it. By the way, these are input 0. I'm just manually putting 0 here because Zelda 2 is a one-player game. But if you were to, say, have a second controller plugged in, which is necessary for being able to do some developer hacky stuff in the actual game, such as initiating a save reset, which is used quite often in speedrunning to warp Link around, then you would have like a variable here, call it, let's see, input index or something like that, right? And just set that to 0, and you can then have input index here, and then you can change the input index according to whatever you need. So if the player is player 0, then it's if it's the first player object created, then it would assign it an input of 0. Then for every additional player object created, it increments by 1. That way you could have multiple controllers creating different copies of the same object in the room, and they all have their own assigned controller. So that's very useful to know about as well. So then after we check to see if we're pressing left, right, or up and down, then we want to check and see if we want to change our what direction Link is facing. So if x underscore input underscore, and this here, typically if you're doing OR, you'd have doubles of this, but in this case we're going to do a bitwise OR, which is used for fancy math. And in this case, what it basically says is if X input or all right, so how does this work? This is the bitwise OR, and by using it in this case in this way, what I'm essentially doing is the equivalent of saying if X underscore input underscore does not equal 0, or Y underscore input underscore does not equal 0, do something, right? But I saved myself from having to do a does not equal for both of those variables by using the bitwise version, which basically says in this case, if X input is compared to Y input, and if either one of them is not 0 or not the same, I should say, if either one of them is not 0, then the value will be 1. So if you're 0 and you're 1, the value will be 1. If you're 1 and you're 0, the value will be 1. If you're 1 and 1, the value will be 1. But if you're both 0 and 0, then the value will be 0. So that's how you do it. And what we're doing here is we're going to go var underscore input underscore direction, not direction is equal to underscore direction 0 x underscore input underscore y underscore input underscore, and so. All right, so what we're doing here is we have a unit circle, which is from 0 to 360 if you have taken your geometry courses or your trigonometry courses. And what we are doing here is, let's see if I can kind of have these both open on the side here. Oh, yeah, I could just do that, can't I? And no, I wasn't trying to maximize it on the other window. So what we got here is input direction, and we have from 0, 0 right here to x input, y input. So in this case, let's say it is 0, 0. Then it would basically be pointing towards the center of the 0. But if we have x input of 1 and our y input is 0, then we would move from 0, 0 to 1, 0. Except it's labeled as -1, 0 on this because I have no idea why they're backwards here, at least in the x direction. Anyways, so this would be 1, 0, and that is right, as you can see. Then if we had -1, and so left 0, then we'd be going left. And of course, on a unit circle, right is 0 degrees, left is 180 degrees, as you can see right there. And if we had 1 and 1, then we'd have 45 degrees, 1 and 1. Then if we have -1 and 1, we'd have 135 degrees. So this is how we use the unit circle here to determine our input direction. So this would be, a diagonal right, and this would be a diagonal left over here, and down, and so on and so forth. So what we're going to do with all that? Well, we'll see here in just a second. There you are. What we're going to do this for is to change our targeting direction and our facing direction. So what I have here is our target direction. Target direction is the actual direction that you are. Whoops, excuse me, I just hit my microphone there. Is the actual direction that you are pointing in. So in this case, we're going to be going with by 45 degrees. So that means we have any of 8 directions. So because 360 divided by 45 is a whole number. So that's how it works out for us. And then if target underscore direction underscore is equal to 8, target underscore direction underscore is equal to 0. Technically, this should never happen, but just in case, what we're basically saying here is if you get an 8, 8 is the same as facing to the right. So might as well just make it a 0, just to make it easier on the on your functions that are handling stuff. Then last but not least, we have if x underscore input underscore does not equal 0. So if the player is pressing left or right, then in this case specifically, so target direction, as I said, can be any direction, but our facing direction can only be left or right because Link is a side scroller and can only face left and right in this instance. I mean, if he had more sprites for the various different directions, then he could face other directions than left or right. But in this case, he only has left and right facing sprites. So we want to only change the facing direction when you're pressing left or right. X underscore input underscore greater than 0. Right. Otherwise, do 4 dot left. So if if your X input is 1, then Link is facing right. If your X input is -1, then Link is facing left. All right, so next up in our tour de force here, let's see here, transition checks. Now we won't do that until we get to actually leaving the room. Damage checks, we won't do that until we get around to actually setting up the damage. State execution, that should be simple enough. We just need to have a variable here. Set your manifest sprite change to false. Event underscore user state underscore, and if not manual underscore sprite underscore change, and in this case sprite underscore state underscore facing underscore direction underscore not equal no one. And then sprite underscore index is equal to sprite underscore state underscore facing underscore direction underscore, and done. So what this does is if in our state execution we change manual sprite change to true, then instead of relying on the state itself to change our sprite, then we will manually change our sprite index to whatever we need it to be. Right? Oh, this is kind of redundant. I'll probably be rethinking it in my future episodes because, well, my future series, because I can think of better ways to do this now. Experience handling we're not going to do. Positional clamping. No clamping. Because Link walks off the sides of the screen for transitions. So we're not going to keep Link clamped to the room, unlike normal. Oops. I didn't want to do that. Let's come over to our timers real quick. And I've over-provisioned these a bit, but, you know, it doesn't really matter too much. We need to do our iframe timer. If it does not equal -1, then approach our iframe timer to -1 by 1. This is basically me proofing the game against the problems with HTML5, which is basically that variables can drift us very slightly away from true integer values. But in this case, by using approach, I guarantee that it will always be an integer value. So, because approach clamps, so you can't go over. And if iframe timer is equal to 0, then iframes is equal to false. I could probably move this over to like damage or something, but I have it down here. So let's see where we at on time. We got plenty of time. So we have ground check and wall check still that I need to put it together, and some other stuff too, but we'll get around to it later. Experience handling, damage check, transition check, talk box. We'll get around to that when we set up talk boxes. Our wall and ground check are going to be important here. First off, be our wall check. Let's bring this in. So basically, we're checking on our left or our right if tile meeting collisions x -1 or x +1. So if our hitbox +1 or hitbox -1 is touching a solid wall, then we have a wall on our left or right. And we have wall left and wall right variables so that we can more fine granulate to which side it's actually on. But the main reason why we have this is so that if a Link walks up against a wall, he doesn't keep animating his walk cycle while you try to move into the wall. And this is important because the original game, he did not do that. If he tried to keep walking into a wall, he'd keep walking into a wall. And I just set this up as a way around that because it kind of annoyed me. So, you know. And last but not least, our ground check. Ground check is basically the same as the other stuff that I've done previously. It looks kind of complicated, but it's mostly just a repetition. So we have our left and our right corners, so P1, P2, P3, P4. So this would be our B box left, B box bottom, and our B box left, B box bottom plus 1. So why do we have the difference? Well, it comes down to, if we come back to our room here, you got these platforms here. So Link can jump through these platforms, but when he's inside of the tile that the platform's on, we don't want him to be detecting it as a solid and stopping his movement all of a sudden. So we don't want him to get stuck inside of these things. So therefore we check both at the inside of the hitbox and the outside of the hitbox for what's going on. And if he's inside of the tile, the platform tile, so if he's inside the platform tile, both inside and outside of the hitbox, then that means he's still moving through the tile on his way up. So we can ignore the floor. And if his the inside of his hitbox is not touching a platform tile, but the bottom of his hitbox is touching a hitbox tile, then that means we're walking on top, so treat it as a floor at that point. That'll be what we use it for. And we do that for both corners, so left corner, right corner. Then we have a collision line, which we use for detecting boxes, or objects, I should say. Then we say if on ground, then we do a bunch of checks here. So if on our left corner there is a platform, and so if there is no platform on our left corner and there is no ladder on our left corner that is inside, and there is, so this is like I was saying, if the inside of our hitbox is above, but the bottom of our below our hitbox is inside, then we are on ground. So it turns that to on ground at that point because we're treating that as walking on ground. And same thing, except this is for the right corner now. Then if P1 is equal to ladder, and then we are touching a corner. So if P1 is a ladder, and then P2 is a solid or a platform. So why did I do that exactly? So P1, so if our corner, oh yeah, so if I'm walking through a ladder, I don't end up treating it as the floor. I don't want to be treating the ladder as a floor. And if P5 does not equal no one. So that's just basically this guy if we're not touching that. So in all these cases here, kind of confusing a little bit, I hope, but if you have any questions, you can refer to them, but it should be all right. It's just saying if any of these conditions apply, then we are on the ground. The super condition to all that being, of course, applied underscore y speed is equal to 0. So basically, if we're on the ground, our collision system should have detected it and set our y speed to 0 already. So if our y speed is 0, then of course we're probably on the ground at this point. And of course, it could be that we're in mid-air and if we're in midair and we're at the top of our jump arc, then you could potentially be considered on ground if it was just that. But we got all this other stuff to detect as well. All right, so I think that should be enough to cover what we got going here. So, yeah, thank you everybody for watching, and take it away past me with some Patreon names. I'd like to thank my Legacy Patreon sponsors, James Burton, JD Lowe, Suli, and Vazia. I'd also like to thank my current Patreon sponsors, Kenneth Klein and Vladimir. Your support helps the NES GameMaker be made and to continue to grow, and I hope that you all continue to have good luck with your programming.